I am on page 98 of the exercise book. Questions 4 and 5 are based on the information below. The function represents the total cost for a company to print flyers, where X is the number of flyers printed. And I believe they mean flyers, F-L-Y-E-R-S. What is the total cost to print 250 flyers? Well, cost is 49 cents a flyer plus $44.95. So when you want 250 flyers, you will have 49 cents times 250 plus $44.95. And that will be 250 times 49 cents is $122.50 plus the $44.95. So the output will be $167.45. I like C on that one. And then which statement is not true? It cost $45.44 to print one flyer. The input of the function is the number of flyers printed. The output of the function is the total cost. The function is 1-to-1, or it cost $145.44 to print 100 flyers. Well, math is required on two of these. The first one, let me get the formula. It's f of x is 49 cents times the number of flyers plus $44.95. So if we want one flyer, we'll have 49 cents for that one flyer plus this flat rate. And so that's going to be 49 cents plus $44.95. I believe that one's true, but let's see. I don't trust myself at this time of night. 45.44. So A is true. B, the input, that's the X, of the function is the number of flyers printed. That is a true statement. The output, that's the Y, is the total cost. That is a true statement. The function is 1-to-1. That is a true statement because the price changes with every flyer. So I am betting that E is the answer, but let's prove it, because it's very possible, as you well know, that I could have made a mistake. So let me erase that line, and we will see what we get. It cost $145.44 to print 100 flyers. So when F is input with 100, we have 49 cents times 100 plus $44.95. So 49 cents times 100, that's going to be $49 plus 44.95. And that is $93.95. So the statement that is not true is E. Linear and quadratic functions. An example of a linear function occurs when there is a set price for a number of products sold. An example of a quadratic function is the height of an object thrown into the air. Questions 6 through 8 are based on the information below. The height in meters of a ball thrown upward into the air from a cliff can be represented by the function where t is the time in seconds after the ball has been thrown. What is the height of the ball in meters 2 seconds after it is thrown? So we are going to take that quadratic function and we are going to input 2 seconds for time. So we have negative 4.9 times 2 squared plus 19.6 times 2 plus 98. So we have negative 4.9 times 4 plus 19.6 times 2, that's 39.2, plus 98. So negative 4.9 times 4 is negative 19.6. And from here you can just type in to your calculator. So you have that negative 19.6 plus 39.2 plus 98 equals 117.6 feet. I'm sorry, meters, not feet. And height at 2 seconds is 117.6. Which description matches the graph of h of t? Is it a standard quadratic or a standard linear? Linear is line. Well, this is not a line. This is a quadratic, so we know it can't be those. It is a parabola, but the question is whether it opens upward or downward. Let me just bring it down here. So h of t is negative 4.9 x, excuse me, I'm used to x, t squared plus 19.6t plus 98. So it is a parabola because of that square, t squared. It is a parabola that opens downward because of that negative sign. The negative makes the parabola open downward. So I want option D for number 7. Okay, number 8. Find the height of the ball 7 seconds after it's thrown. Brody calculated that h of 7 equals negative 4.9. So the first thing I want to do is see if Brody is correct. So h of 7 is negative 4.9 t squared plus 19.6 t. Excuse me. I've already put the 7 in, so I should be substituting that. 7 squared plus 19.6 times 7 plus 98. So we have negative 4.9 times 49 plus 19.6 times 7 plus 98. So let's multiply here and here. So I have 4.9 negative times 49 is negative 240.1. And then 19.6 times 7 is 137.2. And then you just copy the rest and put that into your calculator, just as it's written. So 240.1 negative plus 137.2 plus 98 equals negative 4.9. So h of 7 is negative 4.9. So Brody was correct. A says Brody must have made an error. No, he didn't. The ball has bounced and is moving upward 7 seconds after it's thrown. Not with a negative 4.9. It's not moving upward. The ball has fallen into a hole and is below ground level 7 seconds after it has thrown. Possibly. Let's put a question mark there. The ball reaches the ground sometime before 7 seconds. Possibly. After 7 seconds, the ball has rolled 4.9 meters from the point where it hit the ground. Well, that would not be negative. If it rolled, it would be a constant value. So that is not the answer. So it's either C or D. Now, let's really focus on what this is saying. Remember what 7 is. 7 seconds. This is saying the height at 7 seconds would be negative 4.9. So what that tells me is that D is correct. The ball touched the ground sometime before 7 seconds. Between 6 and 7, the ball hit the ground. Nothing is mentioned about a hole, so we couldn't make that assumption just because it could be. But D is a very valid option, that the ball touched the ground between 6 and 7 seconds.